Hi everyone, welcome to the lecture session on complex variables 2. Today we are going to discuss conformal transformation, that is discussion of W is Z square. So the W can be written as U plus IV, and in the Cartesian form we are taking Z as X plus IY. Squaring Z square will be X plus IY the whole square. So X square plus IY square plus 2IXY, it takes the real part of this as X squared minus Y square, and the imaginary part is 2XY. Let's take the first case, that is when X is a constant. X is C1, where C1 is a constant. Therefore, equation 1 implies U is equal to C squared minus, that is C1 squared minus Y squared. And equation 2 implies V equal to 2C1 into Y. That is, Y is V by 2C1. Substitute Y value in U, which gives U equals to C1 squared minus V square by 4C1 square. Rearranging, we get V squared by 4C1 square is C1 squared minus of U. That is, on cross multiplication, V square will be 4C1 square of C1 squared minus U, or taking the minus sign common, we get 4C1 square of U minus C1 square. This is a parabola in the W plane, symmetrical about the real axis with its vertex at C1 square, 0 and focus at the origin. It may be observed that the line x is equals to minus C1 is also transformed into the same parabola. Case 2. Let us take y as a constant, that is y equals to C2 or C2 is a constant. Therefore, equation 1 implies u equals to x squared minus C2 square, and equation 2 implies v equals to 2x C2. Now x equals to v by 2C2, which on substituting in u, we get u as v square by 4C2 square minus C2 square. Rearranging, we get v square by 4C2 square is equal to u plus C2 square, which gives us v square is 4C2 square into u plus C2 square. This is also a parabola in the W plane, which is symmetrical about the real axis whose vertex is at minus C2 square, 0 and focus at the origin. Also, the line y equals to minus C2 is transformed into the same parabola just like when x is a constant. Now we can see in the diagram when x is a constant, that is c1, we are getting a parabola, and when x is a minus a constant, then also we are getting a parabola, and when y is a constant, again we are getting a parabola which is symmetrical about a real axis. When y is a constant, that is a negative constant, then also we are getting a parabola which is symmetrical about x-axis. So this is about the conformal transformation when we are taking it as a Cartesian form. Now let us consider a circle with center as origin and radius r in the z-plane. That is, mod z is equals to r. Therefore, z equals to r into e power I theta. When we take w is equals to z square, we get r into e power I phi as r e power I theta the whole square, that is r square e power I 2 theta, and therefore capital R is r square and phi is 2 phi. And w is equal to r square e power 2I theta. This is also a circle in the w plane having radius r square and subtending an angle of 2 theta at the origin. And hence we conclude that a circle with center as origin and radius r in the z plane maps onto a circle with center as origin and radius r square in the w plane. Here we can see in the z plane r, which is making an angle of theta, and here it will be traced as r square, that is making an angle of 2 theta in the w plane with u and v as a real and imaginary axis. Thank you.